Uh, Here I'm discussing the fourth case, last one, where is clock is high and your j and k that is equal to 1. So in this case, we just see the value of your q and q complement, that what are the values for these two outputs. So for this we just have to do some analysis, and for that analysis we just assume that your q is equal to 0 and your q complement is equal to 1. So here is q is equal to 0 and q complement is equal to 1. So here you can see that we are giving the input for these two NAND gates. This one is the third input for your q. For the second NAND gate, this one is your first NAND gate, this one is your second NAND gate. So here we are giving as the third input for your this second NAND gate, as your q is equal to 0, j and k that is equal to 1, that is your last case, and clock is high in this case. And here you can see that we are giving the q complement as the input to the first NAND gate. So here is q is equal to q complement that is equal to 1. So here is the third input that is equal to 1, clock is high, that is also equal to 1. Here is q is 0, that is 0, and clock is high. So here you can see that k is 1, clock is 1, and your q is 0. And in this case, for the first NAND gate, you see that uh, this one your q complement that is 1, j is 1, and clock is 1. Now you have to operate these two NAND gates, and I think all of you know that how to operate these NAND gates. So firstly perform the AND gate, and then just do the complement. So 1 and 1 that is 1, and 1 and 1 that is 1. So here you see you're having 0. For that 1 is the complement is 0. So here is 1 and 1 that is 0. 1 and 1 that is 1. So 1 and 0 that is 0, and for 0 the complement is 1. And now this one is 0 and 1. So I think next you having your, this one is nothing but your SR latch. So 0, when you're having giving the input 0 and for the SR latch, then this one is nothing but the output is 1 and 0. Now the outputs are to be changed. Now at this point, now this one is 1, and at this point this one is nothing but 0. So now this one is the reversible. Now this one is 0 1 1, and this one is 1 1 1. So now the output of these two NAND gate, here is 1 and here is 0. So whenever you're giving this one to this SR latch, so the output is now nothing but the 0 and 1. So now the here you can see that the value of q and complement is to be changed from 1 to 0, 0 to 1. Now if you are giving the input to these two NAND gates, now the output again to be changed, that is 0 and 1. So for 0 and 1, this one is nothing but 1 and 0. So here you can see that the output of your q and complement, when your j and k that is equal to 1, that is to be occur in this way, that is q is 0 1 0 1 0 1, and your q complement is equal to 1 0 1 0 1 0. So here you can see that is the racing between this 0 and 1. So whenever your q is changing from 0 to 1, 1 to 0, 0 to 1, 1 to 0, 0 to 1, and here is your q complement that is changing from 1 to 0, 0 to 1, 1 to 0, 0 to 1, and 1 to 0. So this type of state is nothing we know as known as that is the toggle state, or you can also say that the racing between these 0 and 1. So in the truth table of your Next one is your truth table of J and K. Whenever this J and K is having the same truth table as your S and R truth table, आप चाहें तो इसको ड्राइव कर सकते हैं. मैं यहाँ पे जस्ट लास्ट स्टेट लिखूँगी, दैट इज़ इनवैलिड फॉर एस एंड आर. whenever your S and R both are high and your clock is high, then that is the invalid state. But in case of your J and K, this you can see that this one is to be occur as your toggling between your 0 and 1, 0 and 1. So here you can see that here you having your Q and plus 1, that is the output. You're having the three inputs variables, that is your clock, J and K. So whenever your clock is 0, so whatever the value of J and K, this one is remain as your memory, or you can say that the previous state. So now for this 0, J and K having the four possible combination, that is your 0 1 1 0 1 1. So in all that cases, your the output of J Q n plus 1, that is nothing but your next state is Qn. जैसा हमने SR में डिटेल में पढ़ा था, हाउ दिस Qn और मेमोरी इज टू बी ऑब्टेन्ड, अब वहाँ से चेक कर सकते हैं फिर से. सो नाउ व्हेनेवर योर क्लॉक इज हाई, J and K is 0 0, clock is high 0 and 1, clock is high 1 0, and last case when your clock is high, the value of J and K is also 1 1. So whenever this one is 0, this one is nothing but your previous state. So previous state को हमने Qn आपका suppose किया था, that your previous state is to be denoted by your Qn. So whenever this one is your 0 1, this one is your 0 1 0, this one is your 1. And in the last case, whenever this one is the, that is invalid case in case of your SR, but by using your JK flip-flop, we are obtaining this last stage, and that is your this one is nothing but your Qn complement. So as you see that here, this Qn plus 1, that is the output, that is nothing but your next state. So here you can see that the value of Q and Q complement, that is your 0 1 0 1. So if your Qn plus 1 is 0, then the next state is 1, that is nothing but the complement of the previous state. So the previous state is denoted by your Qn. So we are taking here the Qn complement, and this one is representing your toggling. So this is the truth table, and by using of your JK flip-flop, and by using this truth table of your JK flip-flop, you are able to obtain your characteristic table of J and K. And also by using your characteristic table, just obtain the excitation table of J and K.